Hey, what's going on? It's Justin Dickmeyer from EngineerInTrainingMA.com, and in this video we're going to review critical points. We say that x equals c is a critical point of the function f of x if f of c exists and if either of the following are true. F prime of c is equal to 0 or f prime of c doesn't exist. So if these two, either one of these are true, then x equal to c is a critical point. Now the best way to reinforce our understanding of critical points is to work some examples. So let's just jump into some examples here. Let's determine all the critical points for the function fx is equal to 6x to the 5th plus 33x to the 4th minus 30x to the 3rd plus 100. This function looks complicated right off the bat, but it's fairly simple if you just step through the process of determining the critical points. So the first step is to find the derivative of the function, because we want to determine if f prime of c at whatever point is equal to 0 or f prime of c doesn't exist. That's how we determine our critical points. So f prime of c is equal to 30x to the 4th plus 132x to the 3rd minus 90x squared. Now let's factor this equation as much as we can. This will help us find the critical points, or where the function, the derivative of the function, is equal to 0. So we got 6x squared times 5x squared plus 22x minus 15. And we can break that down even further. 6x squared multiplied by 5x minus 3 times x plus 5. So now all we need to do is, since we're factored out, we just need to set this derivative for this function against 0 and determine what the values of x will make this a true statement. And we see that x is equal to -5. We'll make this function equal to 0. X is equal to 0, as well as x is equal to 3/5. So our three critical points in this case are going to be x equals -5, x equals 0, and x is equal to 3/5. So polynomials are fairly simple functions to find critical points for, provided the degree doesn't get so large that we have trouble finding the roots of the derivative. However, oftentimes we aren't given functions like this that are easy to solve. So let's look at a few examples that are a little bit more difficult. Let's say that we want to determine the critical points of the function ht is equal to 10 t e to the 3 minus t squared. So this one looks more difficult right off the bat. Even though that last polynomial seemed difficult, this one seems even more so. So the derivative of h of t, that's our first step. The derivative of h prime of t is, the derivative of ht is 10 e to the 3 minus t squared plus 10 t e to the 3 minus t squared times minus 2t, which simplifies to 10 e to the 3 minus t squared minus 20 t squared e to the 3 minus t squared. So we can factor this as well down a little bit. Let's just pull 10e to the 3 minus t squared out, which gives us 1 minus 2t squared inside. And now this function will exist everywhere, so there's no critical points where the derivative of this function will not exist. So no critical points will come from that. Now determining where this function is 0 is easier than it looks. We know that exponentials are never 0, and so the only way a derivative will be 0 is if we take and try to make this term right here equal to 0, because we know this will never be 0. So pulling that out, we want to determine when 1 minus t2 squared is equal to 0. So we got 1 is equal to 2t squared, which means that t squared is equal to 1/2, or t is equal to plus or minus 1 over the square root of 2. So our two critical points now are plus 1 divided by the square root of 2 and minus 1 divided by the square root of 2. Those are our critical points for this given function. So let's move on to defining how to determine if a critical point is a local minimum or maximum. Now, using what is called the second derivative test, we can determine, given a critical point C, whether or not the function is, or that local point is a minimum or a maximum. Now the second derivative test tells us this: if f double prime of c is greater than 0, then f prime of x is increasing in an interval around that point. Therefore C is a local minimum. So if f double prime of c is greater than 0, then C is a local minimum. Now if f double prime of c is less than 0, then f prime of x is decreasing in an interval around that point C. Therefore, C is a local maximum. So if f double prime is less than 0, then C is a local maximum. So let's take a quick look at how we could use this second derivative test to determine whether a critical point is a local minimum or a local maximum. So let's find the local characteristics of f of x is equal to x to the 5th minus 5x. So the first step is obviously to take the derivative. F prime of x is equal to 5x to the 4th minus 5. So the critical points are the roots of the equation where f prime of x is equal to 0. So factoring, we get 5x minus 1, x plus 1, x squared plus 1. So we find that the critical points are going to be x is equal to plus or minus 1, just by observation here. We plug in -1, we're going to get this term to be 0, which makes the whole function 0. If we plug in 1, then this term is going to be 0. So just through observation, we see that the critical points are going to be plus or minus -1. Now let's use the second derivative test to determine if plus 1 is a local minimum or maximum, and if -1 is a local minimum or maximum. So at x equal 1, f double prime of x, well, let's first define what f double, the second derivative is. The second derivative is going to be 20x to the 3rd. So let's just plug in 1, 21 to the 3rd, which is equal to 20, which is greater than 0. And since that is greater than 0, then we know that at 1, that's going to be a local minimum. Now f double prime of x at x is equal to -1. We got -20, which is less than 0. So at -1, that function is actually a local maximum. So that's how we use the second derivative test after finding the critical points to determine whether a function has a local minimum or maximum at those critical points. So that's all I got for you guys today. There's another review of critical points. Go ahead head on over to my website, EngineerInTrainingMA.com, and send me some suggestions, some feedback. Sign up for the free Engineer in Training Exam EIT Preparation Boot Camp. Send me some questions as well if you have any that are on your mind or that are pressing. But until next time, we'll be talking. All right, take care. Bye.